All right, so in our last video, we we declared a variable, we assigned it a value, and then we wrote a debug.log message to display in the console tab over in Unity what the value is that we had saved in that. Now, we have our max health for our character defined here, but we don't want him to just have max health. We need to be able to take damage from enemies in the game. So let's do this. I'm going to delete this debug.log message because it's just there for us to be able to check our code. I'm going to delete that. And let's go up here where we were declaring variables, and let's declare another variable called current health. But this time, let's not use an integer variable. Let's use a number that we can actually have decimal points in. This is going to be called a float number. So the float number will declare our variable called current health. So go ahead and do that. But first, I want to talk a little bit about what is a float number. Let's think a little bit about what numbers look like. So if I was to have this number, 123, right? For the computer, that means that it has to store a 1, it has to store a 2, and it has to store a 3. Now, if I have 12.3, to the computer, this looks very similar to this. It has to store a 1, it has to store a 2, and it has to store a 3. The way that it stores this information is almost exactly the same as how it stores this information, except that it says, oh, wait, I have to break this number in half and put a decimal point somewhere in there. We also might have 1.23, right? So basically, this over here and these are floating point numbers. We have a point that we're going to put in there, and it could sort of float to wherever it needs to float to in the number to break it up in the correct way. So the way that the computer actually has to allocate some memory for it to hold this entire number is going to be different than if it was just an integer number. It knows with an integer number, it just has to store some numbers, right? A 1, a 2, a 3. In a floating point number, it has to store not only the numbers, but it has to also be able to keep track of where in that flow of numbers it's supposed to put a decimal point. So that's what a floating point number is. So our current health, because we've declared it as a floating point number, that means that we can have a health value currently of not just 100 or 99 or 5, but we could have, 99.9, 99.8. We get those in-between values. And honestly, I don't know if we need those in our game, but maybe we do. Maybe we do. So we've given ourselves the option here by creating it as a floating point number. Now, in our start function, we're going to do this. We need to assign a value to our current health. Yeah, our maximum health that we could have is 100, but what is our current health at the beginning of the game? Well, full health, probably, right? So we're going to give a value to current health. So we're going to say current health, that's guessed for us. Current health is going to be equal to, well, max health, right? So we don't have to say 100 again. It a lot of times is smoother to just say whatever number is going to be in here, go inside of this variable and take its number and put that in here. Now, it actually would be simpler for us to just type a 100 right here. But you got to remember that you're not always going to be dealing with extremely simple pieces of 2 lines of code here. Sometimes you're going to be, instead of dealing with 2 lines of code, you're going to be writing and have 100 lines of code. And maybe in that 100 lines of code, you're going to have 20 different places where this number has to go into the appropriate variables the correct way. And you don't want to have to go to 20 different places. If we decide that this number is not going to be 100, but it's going to be 1,000 instead, maybe that's a better way for us to run the game because we changed our mind later. You don't want to have to go and track down all 20 places where that number is supposed to be put in this way. Instead, just say, okay, the current health is based on whatever the max health is, right? yeah, we gave an actual number up here, but let's not give an actual number here. Let's just go to the max health and use whatever it has. That's what the point was, right? So a lot of times, passing numbers around with variables is a lot more efficient as your code develops, as you make changes and fine-tune the code of your game. You're gonna want to not have to go to a billion different places to change values. Use variables for that instead. I'm gonna leave this at 100. So max health is going to be 100, and at the beginning of the game, our current health is going to be 100 also. Congratulations. I assume you've done that now. You've declared 2 variables and assigned values to both of those. Now, what I want to do is let's simulate a way to take damage. We don't want to have our current health be 100 all the way through the game, right? If a Tyrannosaur jumps on us and starts biting us, our health can't stay at 100. It's supposed to go away. So, what I want to do is, instead of having to create an enemy and give it code to be able to come at us and damage us somehow, I'm just going to say, you know what, let's just press a key. And for right now, that will be the thing that says, oh, we took damage, right? Okay, so I'm going to use the B key because we got bit by a Tyrannosaurus. And whenever I press the B key, that means we got bit, and we'll get to see the value in our current health is going to be lowered. So to do this, we're going to need to write an if statement. So first, before I go and explain a ton about what this is, let's just write the basic structure for an if statement. It's actually going to look a lot like these functions. Here we have a definition of the update function. Notice what we have first is we've got some text, right? Then we have some parentheses, and it's followed by a set of brackets underneath it. Your if statement should look exactly like that. So we want this to be inside the update function. The reason why it's going to be inside the update function is because every time that the computer recalculates everything in the game, it wants to check to see if right then did we press the B key, right? That's what's going to trigger this. So it's going to check over and over and over and over and over to see if we've pressed it every time that runs the update function. So inside the update function, inside the brackets here, excuse me, we're going to write our if statement. So again, some text followed by parentheses, followed by brackets underneath. So here we go. If space, open and close parentheses, space, and then I'm going to type my first curly bracket that is above your enter key right next to the letter P. I'm going to hit shift and I'm going to type 1 bracket. I only typed 1 bracket there. And because Visual Studio is recognizing that that brackets come in pairs, right? You have an open bracket and you have a closed bracket. So I just typed the first bracket and it put a space in there and the second bracket. Now, I haven't typed anything else. I just typed that first bracket. I'm going to hit enter right now and watch what happens. Enter. And it pushes those brackets down underneath into that very organized and pretty looking arrangement that I like so much. Okay, now that's our complete if statement. Now we need to have, we need to populate it with the actual code. There's going to be 2 things that, 2 different pieces of code that we need to put in here. The first is inside the parentheses, we are going to need to put some code in here to tell it what is supposed to trigger this thing. And then inside the brackets, we're going to put the code that says when the thing is triggered, what is it supposed to do? So the thing that's supposed to trigger this is that we're going to press the B key. And here's how we're going to do that. We're going to go to the computer's input system. And in the input system, we're going to grab a function called getKey. We've got 3 of these. There's 3 of them. One's called getKey, one's called getKeyUp, and one's called getKeyDown. And I want to talk quickly about those before we continue. When you press a key on the keyboard, there are 3 distinct phases of that. The first one is that the key is pressed downwards, right? It actually moves down as you push on it, right? The second phase is that it is down. It's just held down for a moment. And then the third phase is that you release it and it pops back up. So that's what these three different phases are. Get key down means that it actually has a downward motion at this very instant. Get key means it's being held down, but there is no motion. And get key up means that it's moving upwards and is being released right this moment. So you might see this in a game where, let's say you have the space bar to shoot, right? You've got your energy cannon or whatever. So you're going to press the space bar. When you press it down, if you just tap the thing, it goes down and up kind of semi-instantaneously. So the game just fires your little projectile, right? But if you press the space bar key and hold it down, it actually doesn't shoot. Instead, it starts charging the beam gun, right? So, and then once it's fully charged or halfway charged or whatever you're doing, as soon as you release the key, it fires a larger charged up projectile, right? So you can see how you would want to, in certain instances, access those different phases of a key press in order to have your game act a certain way. So that's kind of cool. In this case, I want this to trigger the instant that I press the thing downwards, and I don't want it to acknowledge anything else. So I'm going to use get key down. Input.get key down, and then it's going to want some parentheses because, yeah, we're pressing a key down, but I haven't told it which key to look for. So here I'm going to, after input.get key down, I've got open and close parentheses, right? Before I tell you what's in here, notice that we've got two sets of parentheses here, right? And if I put my cursor next to them, it shows you, it highlights the pairs. So if I go here at the end of the line, it highlights the very last one, and it highlights the opening parenthesis way back by the word if. And if I put my cursor inside there, it highlights the pair. You've got the open and close. So every one has to have a pair. You can't just have one at the beginning and then two at the end, or one at the beginning, one in the middle, and just one at the end to close it all off. No. Each one has to have an open and a closed parenthesis. Okay, so here we are in the middle. I'm putting my cursor in the middle, and we are going to tell it which key by typing key code. Capital K-E-Y, capital C-O-D-E. And notice it's got a bunch of suggestions for us, right? And we can see key code.capital B is right near the top here. So that actually is what we want. So this is going to the input system, and in the input system, that's what this dot is about. It's saying that get key down is a function that you can find in the input system, and those are all coming from these libraries at the top that have all our pre-made code that we can use. So, and it's supposed to run the function get key down, looking for the B key on your keyboard. Now, this is not a question, is it being pressed down? This is a statement. This is saying the B key is, in fact, being pressed down. An if statement is not checking on something. It's saying, okay, you're saying something is true over here, and we're going to check to see if it's true. This is a true-false check. An if statement is a true-false check. So over here, we're saying that it is true that the B key is being pressed, and the if key is saying, okay, well, we're going to look, and if this is true, then we're going to do this. If this is not true, we're going to skip this and not do it. So basically, it's waiting until this B key press is true before it does our line of code. Okay, so we've got the trigger for our if statement. Now let's write the body of this. So what we want to do is basically we're going to assign a different value into current health, and we're going to need to take damage. So we're reducing the number in here. This is pretty straightforward. We're going to assign a new number into it. So current health, it's going to look a lot like what we did before, is going to now be equal to, well, what? Well, it kind of depends what our current health is, what our new current health is going to be, right? So if a Tyrannosaur jumps on us and like say a Tyrannosaur bite does 10 damage, right? If we're starting with 100 current health value, then when he bites us and it does 10 damage, then that's going to be a value of 90. But if we're already down to 50 health, then when he bites us and does 10 damage, it's going to take us down to 40. So basically what we have to recognize is that the new value is going to be based on what the value in there is at the moment. So in order to determine what the number is going to be that's going to go into current health, we have to grab the number that's already in current health and use that. So we're going to say current health minus, I don't know, 10. And later on, we might rather, instead of saying, oh yeah, minus 10, we might rather have a variable in here that's going to hold any number, right? So if we get bit by a mosquito, it does 1 damage, and if we get bit by a tyrannosaur, maybe it should do 80 damage or something. I don't know. But for right now, we're just going to make sure that we've got this functionality built in so that we can take damage. And you know what? Let's write a debug.log message under this to tell us what our new current health value is. So debug.log, parentheses and a semicolon, and then we're going to put current health is equal to, and then I'm going to add a second thing with a plus sign, is equal to, well, current health, right? And it's gone off the edge here, but you can see we definitely have our semicolon on the end there. So as we get into the game, we're probably going to change this number into a variable or something. And we're probably going to change it so that we're not checking on a B key. We're going to have something in the game actually tell us that we got damaged, right? We're not going to wait for the player to say, oh, I got damaged, so I'll hit the B key and trigger this. We're going to have a different trigger on this. But for right now, this is a way for us to actually get in and manipulate our variables and see if it works or not. So remember to save. Now, let's go over to, back over to Unity. So we'll hit play. And there we are. I'm assuming things are running. I'm going to hit the B key and see what happens. Here's my B. Oh, current health equals 90. If I hit B again, current health equals 80. It is, in fact, every time I take damage, or every time I simulate taking damage by pressing the B key, it's reducing our life. Okay, well, that's pretty cool. That works. It doesn't mean we have a game yet, but we're starting to actually get in and move some numbers around. And that is very important because a lot of things in the game are going to rely on these if statements. We're going to have to check if something is a certain way. Has our character died? Did we touch the chest and pick up the item? You know, there's going to be a ton of things that are based on these if statements. So learning how to properly write an if statement, getting used to writing the structure first before you put in any of the code, right? So put in if, put in the 2 parentheses, put in the brackets, make sure they're pretty before you start typing any of the code for the trigger or any of the code down here in the body of it. Making sure that you've got all that really, really solid and you're feeling comfortable with it is going to be really important, and it's going to help you get things right the first time and not have to track down a whole bunch of problems. Okay, so that's enough for this video. Make sure that your game is looking like this and acting like this, and we will move forward from there.